Welcome to another coding tutorial, and in today's video, I'm going to show you how to create this Starfield effect using particle systems in 3D. If you're new to particle systems, I recommend that you watch my other video on the basics of particle systems first, where I talk about what a particle system is and also lay out the key steps in creating a particle system, and systems of particle systems. But if you want to get more practice, this one is a good one for you. We're going to start by creating just one particle, and because we're going to be doing this in 3D, first we need to change from the 2D rendering mode to the 3D mode, and we can do that by providing a third argument into the create canvas function, WebGL. Next, I'm going to draw a cube or a box, and I can use a built-in function called box and provide size as an argument. How about we put it as 50? What do you notice here? The box is drawn in the middle of the canvas, meaning that the origin points between the 2D and the 3D rendering modes are also different. In the 3D rendering mode, the origin point is in the middle of the canvas. The second thing that I want you to notice is also that we only provide size as an argument into the box function here, right? But what if we want to locate this box at a different point? What we need to do is that we need to use a translate function to actually move the origin point around. So let's say that we want to move it by 100 pixels to the right. We just need to use a translate function and move it by 100, 0. And that's how we do it. All right, I'm going to delete this and move it back. How about I put in no fill? The third thing I want you to notice is if I draw an ellipse at the origin, you can see that it is drawn in the middle of the cube, right? Meaning that this box here has an origin point that is located in the middle of the box, right? And not at any corner of the box, but in the middle of the box. Now, what if I want to rotate the box? I can use the rotate function. And how about I rotate it by 45 degrees? And because I'm using degrees, let's change the angle mode to degrees. So as you can see here, it is rotating around this axis that is going through the screen, right? Which is the Z axis. So if I put in rotate Z instead of just rotate, it is the exact same thing. But let's say that I change from Z to X. Now it is rotating around the X axis, right? Which is this one. And if I do Y, it is rotating around the axis that is the y-axis here, the vertical one. All right, so I'm going to put it at Z. Now we have a particle that is not moving anywhere. So how about we define a few key variables? So let's start with pose for position. And I'm going to set a position as a vector, and a vector is an object that can hold 2 to 3 values. We're going to use it to hold 2 values, the x and y coordinates of where the middle point of this box is going to be. So we're going to use a method within the vector class called createVector. And then we're going to provide, how about we want to draw it at 100 by 100 from the origin point. And then now, what we want to do is we want to put in the translate function, right? And we want to translate it by pose.x and pose.y. All right, so this box is now drawn at 100 by 100. So I'm going to actually rotate it by 0 first. Next, how about actually we define another variable called size, set it to 50, and replace this 50 with this variable. Right, the next one I want to define is a variable called vel for velocity, which is going to be the speed and the direction that we're going to move this box by. And vel is also going to be a vector. And how about we move it 0 in the x direction, but let's move it up by 1. So we're going to put in -1 here. And to update the position based on this velocity, all we need to do is that we need to add the 2 vectors together. And we can do that using a method called add. So we need to do pose.add and then provide this second vector, vel. And what this does is that it basically adds the x component of the velocity vector to the x component of the position vector. And the same thing goes for the y components of these 2 vectors. And if we click run, now the box is just moving upward. 1 pixel at a time. Great. Now, how about we define the third one? Let's call it acceleration. And acceleration is going to be the change in the velocity or the change in the speed, right? So how about we set it at, let's do 0 and -1. And now I'm actually going to set the initial velocity to be 0, 0. And what we want to do is that we want to update the velocity by the acceleration, right? So we can do the same thing. So we can just add the acceleration vector to the velocity vector. And let's see what happens. You can see that the box is moving upward, but at a faster speed each time because the velocity is updated, right? So if I print vel.y and then acc.y, you can see that the velocity increases over time, right? But the acceleration stays the same. We're basically just adding -1 to the velocity each time the draw loop is called. All right, so that's what we're going to do. That's how we're going to move the particle. But instead of actually moving it at a constant acceleration, I want to actually randomize it, and we can do that using a method within the vector class called random2d. So we need to call it using p5.vector.random2d. And what this does is that it returns a unit vector, which is a vector with a magnitude of 1, but in a random direction. So if I were to print out 3 things, so I want to print out the x component, the y component, and also the magnitude. I can just do acc.mag for the magnitude. All right. So you can see that it has a magnitude of 1, but the direction is random. So that's how we're going to move our particle. So now that we have this, let's put everything into a class called particle. First, we're going to come to this arrow here, click the plus sign, and then click create file. Let's call it particle.js. Then, before we start writing a class, let's go to index.html, and then we're going to come to this line of code here, copy and paste, change the name of this file to the name of the new file, so particle.js, and this is how you integrate a new JavaScript file into the program. Right, so let's go to particle.js, start with the word class. We're going to call it particle. All right, inside the constructor function, what do we need? So we need these 3 things, right, and the size. So how about I just copy this? And then make sure that you put this dot in all of this. So how about instead of giving it 100, 100 here, we're going to provide x and y as the parameter. And then we can set the velocity as 0 to initialize, and then the acceleration will be random. All right, and then for display, what we want to do is we want to display this box here. Make sure to put this dot again. For rotate, we provide it at 0 right now. How about we put in this dot angle and set it as another variable here and initialize it at 0. And then we also need size, right? 50 at this dot size. And then the ellipse function we can delete. All right. Then next we need an update function, right? Which is where we're going to be adding these vectors together. This dot vel, this dot acceleration, this dot pose, this dot vel. Okay, I think we're ready to just create one particle object. Let's call it P, and then P is going to be a new particle object. And where do we want to draw it? Let's draw it at 100 by 100, and then we just do p.update and then p.display. All right. Now let's create a bunch of particles. So how about I change from p here to an array called particles. And then inside here, actually, let's create another variable called num. We want to create, how about we create five particles that we want to create per system. Then now let's write a for loop that goes from I equals to 0 to I less than num, I plus plus. And this is going to be one system of particles, right? We want to create 5 particle objects at what location? How about we actually start it in the middle? And then for update and display, we want to write the for loops again. And instead of using num, I'm going to use particles.length, which should be the same for this case. And then inside here, we're going to update all of the particles and display all of them. All right. Ta-da! Great. I want to change 2 things. The first thing is I want to actually make the size to be a bit smaller. So how about we give the size between 3 and 6. Nice. And it's moving kind of fast. So what I want to do is that I actually want to change the magnitude here from a constant 1 to something different. So I'm going to multiply it, and we can use the method within the vector class called mult. And I want to multiply it by a random number between 0 and 1. And I can just use a random function here, and this will return a number between 0 and 1, but not including 1 actually. Let's try that. All right, so that's good. It's slightly slower. Okay, so this is basically our system of particles, or a particle system. So how about we put it inside a system class? So we're going to do the same thing. Come to this arrow, click the plus sign, click create file. Let's call it system.js. Then do the same thing here to integrate the file into the program. All right, and then we're going to write this class, and this class is going to be called system. Inside the constructor function, what we need is the middle point of where we want to first create these objects, right? So we're going to create a variable called post again, and it is also going to be a vector with 2 parameters, x and y. And then we want these 2, right? We want to create a particles array, and also set a specific number for the number of particles we want in a system. Then also inside the constructor function, we want to create particle objects. So basically inside this system class, we're creating what? We're creating new particle objects. So inside one class, we can call it on another class. So this is exactly what we're doing. We're using a for loop, and we're populating the particles array here with new particles objects. But instead of 0, 0 here, we're going to put in x, y. And then let's do update. Inside update here, what we want is basically this. And I'm actually going to separate update and display. And this one will be for display. Okay, let's go back, and we're gonna create one particle system. Call it PS. PS is going to be a new system, and we're gonna put it in the middle of the canvas, 0, 0. And then we're going to update it, and then we're going to display. and we should get the exact same thing. Oops. Oh, don't forget this dot. This dot, this dot, and this dot. All right. So what is the next thing that we need to do? As you can see here, the particles that are off the screen are actually still part of the particles array. So we want to actually first remove them from the array, right? So to do that, what we need is we need to go back to particle.js. We're going to give it another variable called life, and let's start it at 255. And then inside update, each time we call the update function, we want to decrement this variable by a certain amount. How about we decrement it by 5? And then inside display, to know that this is being decremented visually, we're going to use it as the alpha value for the stroke. Let's give the stroke a white color, and then the alpha value would be this variable here. And then let's click run. All right, so it slowly disappears. Also, let's change the background color to black. All right, so right now the particles disappear, but we have not yet removed it from the array. We're gonna create another variable called done, which is going to be initialized as false because it's not yet done, right? But it is done when what? I'm going to write another method called finished, and we're going to say that if this.life is less than 0, right? Because we keep decrementing it down by 5, it will reach 0 at some point, right? Then that is when this.done will be true. Else, this.done will be false, right? And then we need to, inside update here, also call this method. And we can call a method inside a class by just writing the word this dot and then the name of the method. Okay? And once we do this, how about I first just print this dot done. It's false, 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 true. As you can see, once it's gone, then it becomes true. Then now we want to use this variable here to indicate when to remove the particles from the particles array inside the system class. So inside here, inside the update function, what we're going to do is that we're going to say if this dot particles of I dot done is equals to true, right? Then we want to remove it from the particles array, and we can use a method called splice, which removes an object inside the array. So all we need to do is put in the name of the arrays dot splice, and then we're going to provide two arguments. The first one is the index of the object that we want to remove. So we want to remove it at index I, right? Because if this condition is true, it means that that object of index I is done. And then the second argument is the number of objects that we want to remove from this object. So we're going to put in 1, and by doing this, it's basically just removing this one object. And if I click run here, visually it's still the same. So how about we also print this particles dot length 5 and then 0, right? And as you can see here, it goes from 5 then 2 then 1 then 0. And that is because of the way that we loop it through this particles array right now, which is forward. And we don't want to do it this way because some of the particles are being skipped when being checked. What we want to do is that we want to loop it backwards, and we can do that by first start I equals to this dot particles dot length minus 1, and then the condition will be I more than or equals to 0. Then we're going to decrement it down. And by doing it backwards like this, we're not skipping any of the particles that we're checking. And if I click run, it goes from 5 to 0. Now we have the particle system class, right? How about we create a bunch of particle systems? let's change this from a variable to an array. And then instead of creating the particle system object inside setup, I'm going to actually write a function called mouse clicked. And this is a built-in function within p5.js that gets called every time you click the mouse. All right, so we're going to add a new system object inside the PS array, and we can do that by using the method called push. And this is basically creating a new or pushing a new object inside the array. And where do we want to push it? We want to push it where the mouse is, right? So mouse X and mouse Y. And I'm going to delete this. And then inside draw here, we need a for loop, right? And it's going to go from I equals to 0 to I less than ps.length. I++, and the length will change right over time as we click the mouse. And then we're going to call these two method update and display. All right, let's try it. Do you see that? It's being created here, but I'm clicking my mouse here. Why is that? It is because of the difference in the origin points between the 2D and the 3D mode. Because where my mouse is right now, that is the point 0, 0. So that's why the objects are being called at 0, 0, which is the origin for the 3D mode, right? So what we want to do is we want to translate by negative width divided by 2 and negative height divided by 2. And this should fix the problem. Why do I only get 1? What did I do wrong? Let's come back here. What is it? We use translate and rotate function, which are transformation functions, right? And whenever we use transformation functions, we need to think about whether we want to use two important functions called push and pop, which basically saves the transformation, which are these two, and then return it back to the default transformation setting before we call these functions again. And that's exactly what we want to do. We want to use the push function, which saves these, and then we want to use the pop function here, and it returns it back to where the origin is before we translate and before we rotate it again. So if we do this, and then now the objects are being created where the mouse is. Great. How about we change the colors a little bit? I'm going to make it a rainbow color. So I'm going to start by changing the color mode to HSB, and I'm going to provide the second argument as 255. HSB is a color mode that stands for hue, saturation, and brightness. And basically what we're going to do is that we're going to change the hue value here. We're going to keep saturation at the maximum, which is 255, and then brightness actually is where we're going to provide the this.life argument into. I give it the second argument as 255 to set the range for this color mode. So by providing 255 here, the range is now between 0 and 255. Now what we need is we need to go back to particle.js, and I'm going to set another variable. Let's call it hue value. How about we start it at 0? And then now inside here, we're going to keep stroke as is, but we're going to put in fill. Now I can delete this no fill here. Fill is going to be this dot, hue value, right? Saturation will be at 255, and then the third piece is this dot life. And yeah, let's try it. Also, what we want to do is, because if we do this, it's only red, right? Because we have not changed this value at all. It stays constant at 0. So inside update here, I want to also increment it by, how about 1? Okay, but I also want to set a conditional statement that says if this dot hue value is greater than 255, then let's set it back to 0. And this is just in case, because to be honest, this.life decreases faster than this can actually go over 255. But in case you want to change these variables, so let's say that we do 1 here, and then we change it by 50, right? Now it just moves way too fast. All right, so I'm going to actually set it back at 5, and then this will be 1. Two things that I want to change. The first one is that instead of actually setting the hue value at 0 initially, I want to randomize it, but between just 100 and 150, which gives it a color between this hue, right? Actually, this is too fast. Let's do 1. All right, so by randomize it between 100 and 150, you can see that the starting color is in this bluish value color. Perfect. All right. And then how about we also update the angle, right? Let's rotate it. Let's increment the angle by, how about 3? And this angle is gonna be set here, right? Let's see what this does. All right, so it's rotating the cubes. All right, so now comes the last piece. Let's go back to sketch.js. Instead of actually pushing a particle system where the mouse is, what we're going to do is that we're going to actually use a conditional statement that says if random, and random without providing any arguments actually is the same thing as providing an argument of 1, which returns a value between 0 and 1, not including 1. And we're going to put in if random of 1 is less than, how about 0.3? So basically, we're not adding a particle system every time the draw function is called. We're only adding it when random of 1 is less than 0.3. So we want to add it a little bit less frequently. And we're basically going to push this, right? But I want to push it at, let's just put in 0,0 here. And then because we're putting 0,0 here and it's not based on the mouse location anymore, we can just delete this translate function as well. And before I click run, how about we increase the width here and move it in. Let's try that. And there you go. That is your Starfield effect. Looks kind of nice. This is one implementation of using a particle system to create an interesting effect and also in 3D. So I hope that you give this one a try.